All right, guys, we're starting. This is for AP Stats, Chapter 9 practice test. We're taking a look at some of the answers to the questions we got here. We're going to take a look at questions 1, 2, 3 in this small video. And I thought I'd take this time to show off my exceptionally wonderful hat. It kind of sets the tone for what I have here. So let's get started. Here is our test, just kind of broken down a little bit. And we got number one, a significance test gives a p-value of 0.04. For what values of alpha can we reject the null hypothesis? So remember what that means. We reject the null hypothesis, which is the same as, let's use a fun font. What fun font should we pick today? Mrs. Ferreira likes it when we use papyrus because she can't stand that font. So we're going to use papyrus. Papyrus. Yeah. Oh, why won't you work? Papyrus. No. Will you be? No, you're not papyrus. Okay. That's not good. We're going to spend half of the video trying to get papyrus font, right? Will we just have to use Chris? No. There's no font that it wants to use other than Trebuchet. Huh, interesting. Okay, enough time of that. Values of alpha that we can use to reject the null hypothesis. Basically, we reject the null hypothesis. Oh, look at that. That's Kristen. Hypothesis, if which also means that we have evidence for the alternative hypothesis. Oh, this is a fun font. Alternative hypothesis. If p-value is less than alpha. Okay, so I know that doesn't really answer the question. So what values of alpha will reject the null hypothesis? Well, anything that is any alpha greater than, oh, this is super fun. Look at that. It just went to papyrus. Any alpha greater than 0.04. So for example, then let's actually use an alpha sign here. Alpha equals, I don't know, 0.05. That'll work. What else? Alpha equals 0.10. Those would be our standard alphas. It's worth noting that, note that an alpha of 0.01 will not reject the null hypothesis. Okay. So yeah, remember that the main thing here is that we are talking about the alternative hypothesis. That's a, when you're doing an experiment, you're really concerned about the alternative hypothesis, not so much the null hypothesis. So when you write your conclusion, you want to talk about the alternative hypothesis. So if alpha is 0.01, then basically you didn't prove your alternative hypothesis. So hopefully that's it for number one. Let's check out number two. Maybe get rid of some of that white space. Which one do we like better, Kristen, or let's go with Kristen. Let's turn that all into Kristen. She's a good one. Okay, so number two then. A significance test allows you to reject a hypothesis H0, which is the null hypothesis, in favor of the alternative HA at a 5% level of significance. Can we reject at the 10% level? How about at the 1% level? So here the idea is it's kind of vague because you don't really know what what your p-value is. So p-value could be, let's start with that. P-value could be, well, we know that p-value is less than 5%, so it could be 4.9. Right, that's less than 5%. It could be 0.04, 0.02, 0.01, 0.003. Any of those could be our p-value. But for example, p-value could not be 0.054 or even 0.07. Sure. So let's take a look at what those are in common. Can we reject at the null hypothesis at the 10% level? Well, if these are all the values of that could be our p-value, these ones right here, all of those could be rejected at the 10% level. So yes, we can reject at the 10% level. We can reject at the 10% level. What about the 1% level? Well, the thing is that we don't know for sure that our p-value is less than 1%. Notice 0.04 fits our, I don't want to say hypothesis again, but it fits the question. It allows us to reject at the 5% level, but it doesn't allow us to reject at the 1% level. Well, the p-value could be 0.003, but we're not assured that it is 0.003. We just know that it's less than 5%. So we cannot, or maybe it's not that we cannot, but it's possible that we cannot. At the 1% level. We just don't know. So we don't know, we can't reject. So there we go for question 2. Let's make that look like kindergartner wrote it. Yeah, Christian ITC, you my gal. Okay, moving on to question 3, the last one in this one particular video. In a test where mu is 100 against mu is not 100, a sample size of 80 products gave us a test statistic of z equals 0.8 for the test. Well, that's kind of redundant now, isn't it? For the value of the test statistic. What's the p-value of the test? So, really important, this right here, the not equal sign. The not equal sign tells us that we do not have, or we have a two-tailed test. Okay, so this is a two-tailed test. Two-tailed test. That's why that's why I highlighted that. All right, so if it's a two-tailed test, the p-value is going to be equal to two times the probability that z. Well, notice that we have a positive z-score. So when we have a positive z-score, that means that when we calculate our p-value, we're going to go greater than that greater than that test statistic, which means to positive infinity. I think I better draw a picture here with that. So let's see. So our p-value is going to be 2 times the probability that z is greater than 0.08. So let's draw that over here on the side. Computer fall. Do I have? Yes, I do. All right, let's draw a really quick. Here we go. Now, why do you give it to me in that pen? Here we go. Here's our normal curve. Here is, for example, let's say 0.0. Actually, you know, I can do better than that. I know 0.08 isn't there. This is a z-score of 1 here, so 0.08 should be to the left of that. Z equals 0.8. And then also here, this is z equals negative 0.08, which you normally wouldn't care about unless we're looking at a two-tailed test, which we are. So here's our p-value. We're going to calculate this right here. Okay, and notice that does go to positive infinity. So let's grab Mr. Calculator. And we're going to go to a normal CDF. And we're going to go from 0.8 to positive infinity. And I teach all of you to use 1E99. Important also, if we're doing this with z-score, the mean of the z-score is always 0. The standard deviation of a z-score is always 1. Paste, hit it, 0.2119. 0.2119. So this area right here is 0.2119. Okay, that also means that this area here, in consequence, this is also 0.2119. So our p-value is going to be equal to 2 times 0.2119, which by golly, that's 4238. And I don't know what kind of alpha level we're dealing with here, but there's not really an alpha level that would, not a sensible alpha level for which you would reject the null hypothesis here, or to put it the other way, there's no sensible alpha level for which you would confirm or get evidence for the alternative hypothesis. So if this was your experiment, it's kind of a failure. Okay, so that is, what did I just do? Yeah, there we go. That is questions 1, 2, and 3, and we'll do 4, 5, and 6 in a few minutes.